So in this lecture, let's discuss the first topic, the properties of real numbers. So there are four common properties of real numbers. One is the commutative property. Second is the property of association or the associative property. Third is the distributive property. Fourth is the identity property. So one another that's commonly used is the inverse property. So let's discuss one by one. Commutative property is only useful in addition, so it only works for addition and multiplication. Associative property also works for addition and multiplication. Distributive property requires two properties to act at once, so this is most commonly used for multiplication and addition. Identity, there are two identities, additive and multiplicative. In the same way, you have two common properties for inverse, additive and multiplicative. So let's discuss one by one. So let's start with commutative property. Commutative property basically is the property, it says that if you talk about addition, so the commutative property of addition basically states that the numbers can be added in any order without affecting the sum, which means that if you have two numbers a and b, it can be added as a plus b or b plus a. So this is the commutative property of addition. The same property of multiplication is that the numbers can be multiplied in any order without affecting the product. So a dot b times b is equal to b times a. This is the multiplicative property. Next, let's talk about associative property. Associative property basically associates two quantities and says that however how we group quantities does not have any effect on the total sum. So what does that mean? For example, a plus b plus c. So where you multiply b plus c first and then add a is the same as adding a plus b first and then adding c, also the same as a plus c being added first and then added by b. So however you group the numbers does not matter, with the sum being the same. The same thing for multiplication becomes a times b times c is equal to a times b times c is equal to a times c times b. So this is the associative property of addition and multiplication. Next, let's discuss distributive property. So what is a distributive property? So distributive property basically states that when you distribute, so the product of factors times a sum is the sum of the factors of each of your individual terms. So what does that mean basically? Is that when you multiply a factor, so when you multiply a with b plus c, it's similar to multiplying each of the individual elements inside with the actual number. So this is the distributive property. So for example, if you want to multiply 4 times 12 minus 7 or 12 plus 7, so it can also be written as 4 times 12 plus 4 times 7. So which gives you 48 plus 21, so 28. So which should give you 76. Right, so the number can be distributed over the factors. So this is the idea behind the distributive property. Now, the next property is the property of identity. What does identity basically mean? Identity says that there is a unique number when multiplied with another, when multiplied with a specific number, yields the same number. So for example, when added with the same number, yields the same number. For example, if A is a number and you added something to A, but the final answer is still the same, so that number here is 0, and this 0 is called additive identity. This 0 is called additive identity. In the same way, when A is to be multiplied with a number, if you get A, that number generally is 1. 1 here is multiplicative identity. One here is the multiplicative identity. In the same way, let's discuss the last property, which is the property of inverse, or the inverse property. So the idea here is what number should I add to A so that I get the identity. So here the number is minus A. This minus A is called as additive inverse. In the same way, what number should I multiply with A so that I get the multiplicative identity 1. So that number is 1 by A. This 1 by A is called the multiplicative inverse. So these are the properties of addition and multiplication, and these are the common properties that you will see in general. Now let's talk about expressions. So specifically talking about algebraic expressions. So algebraic expressions in general, or mathematical expressions, are basically made up of constants and variables. So an algebraic expression is a collection of constants and variables. So it's an algebraic expression is a collection of constants and variables combined by joining together with algebraic operations. So algebraic operations are addition, subtraction, multiplication and division. These are all the properties that we generally use. Now, what would be an expression in general? Let's take a simple example. Let's say you have an expression which says minus 3 to the power 5. Minus 3 to the power 5 represents minus 3 times minus 3 times minus 3 times minus 3 times minus 3. So we already did this in exponential notation. But let's say if you introduce a variable also is this exact same. So x times x times x times x times x. So what would happen in an actual algebraic expression? So for example, let's take expression x plus 5. We want to know which is a constant and which is the variable. So in this, x here is the variable because it has no inherent value, and 5 here is the constant because 5 itself is a number with an inherent value. Now the same way, let's say you have another one, say 4 by 3 pi r cube. So here r cube becomes the variable and 4 by 3 pi becomes the constant. Now in the same way, let's try under root 2m cube n square. So in this, write down what is the variable and what are the constants. So here you don't need to write the actually r cube, you can just write r. So in the same way, try this problem where, so pause the video right here, and for this one try to write down which are the constants and which is the variable. So let's continue. How do you evaluate? So evaluation of algebraic expressions. For example, let's say in a problem you have t by 2t minus 1 is the expression, and they are asking you to evaluate for t equal to 10. What do you do here? Here is basically replace t with 10 in the expression. So what do you do here? 10 by 2 times 10 minus 1. So that gives you a value of 10 by 20 minus 1. So that ends up becoming 10 by 90. So if t equal to 10, so then the value for t by 2t minus 1 becomes 10 by 90. So this is how you know the value or how to evaluate an expression. So what do you do in this expression? Basically replace the variable with the value. So that finally gives you the expression. Next. So we talked about algebraic expression. Let's talk about formulas. What is a formula? So before we talk about a formula, let's talk what is an equation. An equation is basically a mathematical statement. So it's basically a mathematical statement that indicates that two expressions are equal. So it's a mathematical statement that says that two equations are equal. Two expressions are equal. For example, if you have an expression, say 2x plus 1, and we write it's equal to 7. Notice that this is an expression, this is an expression. But when you combine both of them with an equality, that combines it to create an equation. So now that we are clear with this equation, let's discuss what's the definition of a formula. So a formula basically is an equation expressing a relationship. So what is the relationship? So it explains the relationship between constants and variables. So it is basically explaining a relationship between constants and variables. For example, we consider a as a variable. So that variable has another expression pi r cube, pi r square. So this here, for example, if you take the area of a particular circle can be evaluated with this formula pi r cube, where pi is the constant and r is the radius, which is a variable. So r here is the variable and pi is the constant. So this is the expression for a formula. Next, let's talk about simplification of algebraic expressions. Let's take a simple example. Let's say I have a variable 3x minus 2y plus x minus 3y minus 7. How would you simplify this? So the first thing that we do here is always try to make sure to add the variables that are common. So what we do here is rearrange the values in such a way that notice that 3x and x are close. So make sure to take the sign whenever you are moving a variable. So you have 3x plus x and there's minus 2y, minus 3y. So you have minus 2y and minus 3y minus 7. So 3x plus x, take each of these values individually, right, and try to make up the final answer. So 3x plus x becomes 4x. So minus 2y minus 3y becomes minus 5y, and it becomes minus 7. So this is the simplified version of the value. Let's take another example. Let's say you have 4t minus 5 by 4s minus of 2 by 3t plus 2s. Now the idea here is to simplify this, but there is a problem here. Notice that there is a minus with a parenthesis. So always remember to evaluate the values in the parenthesis first. So because there is nothing here in the first one, so we can write down that one directly. Right, so that becomes 4t minus 5 by 4s minus, but this minus has to be multiplied with each of these variables. Notice that this minus basically represents minus 1. So what we are doing here, minus 1 into plus 2 by 3t, so it becomes minus 2 by 3t. Next, minus into minus 1 into plus 2s becomes minus 2s. Now again commutative law, pair the equal ones, 4t and minus 2 by 3t. So the value becomes 4t minus 2 by 3t, right, minus 5 by 4s minus 2s. So what we can do here is take the variable common so that you can add the constant. So the variable here is t, so take t common, get 4 minus 2 by 3. In the same way, in the second one, take s constant plus s constant out, so you get minus 5 by 4 minus 2s. Notice that we have taken both minuses inside, that's why we still have plus on the out. So now we have t times 4 minus 2 by 3, so 3/4 becomes 12, so 12 minus 2 by 3 plus s into, next 4 times 2, so minus 5 minus 8 by 4. So that should give you 10 by 4, 10 by 3 into t, so minus 5 minus 8, that should give you a value of minus 13 s by 4. So this is the final answer for the variable. So this is how you simplify the algebraic expressions. Now, so try this one. So 2mn minus 5m plus 3nm plus n. So try to simplify this and write down the value. Also try this one. So 2r minus 5 times 3 minus r plus 4. So try these two problems. So pause the video right here and try these two problems. Let's discuss the next topic, exponents and scientific notation. So what is an exponent? So we already discussed that whenever you have a variable to the power of n, so a here represents the base and n represents the exponent. So exponent basically means that we are multiplying a value that many times. So because it's a power n, we are multiplying it n times. For example, if it is a square, we multiply it twice. If it is a cube, we would have multiplied it thrice. In the same way, if it is a to the power 5, we would have multiplied it 5 times. So this is the concept of an exponent. Now, so let's discuss the first rule of exponents, the product rule. So the product rule basically states that if there are two exponents with the same base but two different exponents, then you can multiply them and add the exponent value. How does that work? For example, let's take a square times a cube. If you separate it into individual values, it becomes a times a cube becomes a times a times a. So when you write down the full value, it should become a to the power 5. But this can also be achieved with the term a to the power m plus n. So where m becomes 2 and n becomes 3. So it becomes 2 plus 3, which eventually leads to the same value, a to the power of 5. This is the product rule of exponents. So when the base is the same, so a power m, so if you have a base that's the same, it becomes a to the power m plus n. So that's the first one. Let's discuss the second one. The quotient rule. So what happens in the quotient rule? So in the quotient rule we have, for example, let's say I am dividing a to the power of m by a to the power of n, provided the base is the same. So then it can be written as a power m minus n. For example, let's take a cube by a square. So if you split it, it becomes a times a times a divided by a times a. So we can cancel a. So you will be left with a to the power of 1, which can also be achieved with the above formula, which gives you a to the power 3 minus 2. So which will also release to the same answer. So this is the quotient rule. So when you take square root of a, it basically means a to the power of 1 by 2. And when you see cubed root of a, it means a to the power of 1 by 3. So in the same way, when you see nth root of a, it means a to the power of 1 by 1. Remember that n into root a is not the same as nth root of a. So we'll discuss more about this in the radical functions, in radical values or radical expressions. So there we'll discuss more, but here just remember the common rule. So next, let's discuss the power rule of exponent. So power rule basically states that you are adding an exponent to another exponent. So that basically makes the product of the exponents. So for example, if you want to find out x square whole cube, so x square whole cube becomes x to the power times 2 times 3 becomes x to the power 6. So this is the idea behind the common concept. So if you want to do this as a proof, so you can also see this way. So it becomes x times x whole cube, which becomes x cube times x cube, which if you add it, we will get the same answer, x to the power 6. So this is the power rule of exponents. Next. So the last one is the zero rule. So the zero rule basically states that any base to the power 0 is always equal to 1. So any base to the power 0 is always equal to 1. How do I know that? For example, if you take t power 8 by t power 8, when you generally have two values that are similar, you just cancel each other. The value is 1. The same thing goes for when you take the formula, when you use the formula for the rule, so subtractive rule, you can write t power 8 minus 8 or the quotient rule, which gives you t to the power 0. So 1 and t to the power 0. So you get the same answer for zero rule. Next, let's discuss the negative rule of exponents. So what is the negative rule here? So negative rule basically states that the negative power of any base is 1 over the actual exponential power without the negative. Or you can also write a power n as 1 by a to the power negative n. So this is the negative rule of exponents. Next. The next one is the power of a product. So when you have two values, for example a and b, and you are giving both of them a power n, so the exponent is to be equally distributed to both the bases. So ab whole to the power n becomes a to the power n into b to the power n. The same way you can also find the power of a quotient. So which is, if you have a by b whole to the power n, that also gives you a to the power n by b to the power n. So this here is the quotient rule for the product. So with that we completed all of the rules. So let me write all of them in a single page. So first is the product rule, a to the power m into a to the power n is equal to a to the power m plus n. The next rule is a to the power m by a to the power n is equal to a to the power m minus n. The next rule is the power. So a to the power m all over n becomes a to the power m times n. The next power is the negative the distribution. So ab whole to the power n becomes a power n times b power n. The quotient a by b whole to the power n becomes a to the power n by b to the power n. The negative, so a to the power negative n becomes 1 by a to the power n. So and the last one, so that with that we end the last and the final one, a to the power negative n becomes 1 by a to the power n. And you can also write the zero rule. So zero rule you can write it as a power 0 is always equal to 1. So this rule basically states that anything to the power 0 is always equal to 1. Now let's try some problems and let's try to use these principles. So this is your formula sheet for this section, so try to screenshot it if you want to. So you can use this as a section of formulas. Now let's try some problems. So let's say I have 6m square n to the power of negative 1 whole to the power whole cube. So the first rule that is to be used is a to the power m whole to the power n becomes a to the power m times n. So it becomes 6 to the power 1 here, so it becomes 1 times 3, which is 3, into m square whole cube into n to the power negative 1 whole cube. So notice that the first rule that we used here is ab whole to the power n becomes a to the power n into b to the power n. Next let's use a to the power m over n, which becomes 6 cube into m to the power 2 times 3 times n to the power negative 1 times 3. So you have 6 cube, which is 216, and m times 2 times 3, so m power 2 times 3 is m power 6 times n to the power negative 1 into 3 becomes negative 3. Next we can use a to the power negative n, which becomes 1 by a to the power n. So n to the power negative 3 is there, so 216 m to the power 6 divided by n cube. So this is the final simplified version of the value. So this is the simplified version. Now let's try another example. Let's say I have u power negative 1 into v divided by v power negative 1 whole square. So the first rule we have to use is a by b whole to the power n becomes a power n by b power n. So you have u power minus v into v whole square divided by v power negative 1 whole square. So that gives you next the power here. So you get ab whole to the power n is equal to a power n into b power n. So it becomes u power negative v. So u power negative 1 whole square into v square divided by v power negative 2. Next, so a power m whole power n becomes a power m times n. So that gives you u power negative 1 times 2 times v square by v power negative 2. So you have u power negative 2 into v square by v power negative 2. Now let's try and separate the v quantities which are similar to each other. So u power negative 2 times v square by v power negative 2. Now let's use the quotient rule. The quotient rule is a power m by a power n becomes a power m minus n. So that becomes u power negative 2 into v power 2 minus of minus 2. Notice that this itself is minus 2. So it becomes 2 power minus of minus 2. So which gives you u power negative 2 into v power. So minus times minus is plus. So you get 2 plus 2. So you end up with u power negative 2 into v to the power 4. So the final answer for this is u power negative 2 into v to the power 4. So this is the final answer. If you want to further simplify it, you can write a power negative n as 1 by a power n. So you can write v power 4 by u square. This is your final answer if you want to write that as well. So just choose the answer that's in the options, whichever is the closest answer, and write down your final answer. Now you try some examples. So let me write down some problems. Minus 2 into a cube into b power minus 1 times 5 times a to the power negative 2 into b square. Next, x square root 2 whole power 4 into x square root 2 whole power negative 4. Next, also try 3w square whole power 5 divided by 6w power negative 2 whole power whole square. So try these three problems. So pause the video right here and try these problems. So in this topic, let's discuss scientific notation. So what is a scientific notation? So any number that's written in the form a times 10 to the power n is called as a scientific notation, where the value of a should always be between 1 and 10. So understand that it can be negative as well. So that's why modulus of a can be between 1 and 10. So it cannot be exceeding 10. So this is the main thing. And n is always an integer. Now let's try and convert some values into specific notations. For example, if you take the number of stars in the Andromeda galaxy, so this is the number that you generally see. Now, how do you convert this into the scientific notation? Number 1, always start at the end and count the number of zeros until you reach an integer. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So now this is the integer. So what do you do now? Is there are 12 places after 1. So now write 1 in the front times 10 to the power and write down the number of places of 0. So 12. This is the value. This is how we write the scientific notation. Let's take another example. Now let's take a smaller number. Now in these numbers, let's take 0.00000143. So let's take this number now. Now how do you count here? Here you count from so here we counted towards the left. Here you're going to count from the right. So to the right, how are you going to count the values? So you're going to start from the first 0. 1, 2, 3, 4, 5, 6. So now we have 6 places. Always count the 0 even before the decimal point as well. So now we have 6 places. Now what do you do with the other numbers? Write down 143 but put a point at 1. So 1.43 into 10 to the power of negative 6. So this is how you convert this value into a scientific notation. So let's take some other examples. Let's say if we have to do it in reverse. Let's do it in reverse. Let's write 7.91 into 10 to the power of negative 7. Now here I'm gonna have to have 7 places. So you're gonna write 0 point. So 1 0 is done. So this is 1, 2, 3, 4, 5, 6, 7. So 7 are done. Next write down the numbers directly. 791. So this is how you end up with the numbers. So if you have any doubts in this, So just just pause the video right here. Now try this problem. So try converting 3.547 into 10 to the power of 14 into the scientific notation, into the general notation, and also try minus 2 into 10 to the power of 6 into the general notation. Now also try 0.94. So try to convert this into the scientific notation. So pause the video right here and try to solve these three problems.